Hi class, today I'm going to go over problem number 10, E and F from page 242 in your textbook. I understand this was a pretty difficult problem. They wanted you to find f of g of x and simplify it completely. This goes back to some pretty heavy algebra where they want you to put g of x inside f of x. So let's talk a little bit about the basics of combining functions or composite functions. They basically want us to use the blue function here as the outer shell. So I'm going to rewrite negative x squared plus 2x plus 3 like that without any x in there. Instead of an x, I'm going to use parentheses. So remember, an x is sort of like a fill in the blank. Now inside of those parentheses, we're going to replace the x, or those blanks, with the other function, g of x. So g of x is playing the role of x in this problem. Before we do that, let's take the red function and let's expand it using foiling. X minus 2 squared means to take x minus 2 times itself. When we FOIL this, we find that we end up with x squared when we do first times first. When we do the outside and the inside, we end up with negative 2x and another negative 2x, giving us negative 4x. And then finally, when we do last times last, we end up with negative 2 times negative 2, which is plus or positive 4. So that is our equivalent expression for g of x that I'm going to use inside this blue function. So I'm going to have negative blank squared plus 2 blank plus 3. Those blanks are taking the place of the old x from the blue function. I'm going to now replace that g of x in both cases with our expanded form, x squared minus 4x plus 4. X squared minus 4x plus 4. Now we're not done. The directions say to we're going to use algebra to simplify and remove all parentheses. Again, this is letter E, number 10 on page 242. All right, to remove all the parentheses, what we need to do again is expand this, and we're going to use the definition of what squaring means. We have the negative sign out front. That just sort of stays there for now. But to square any quantity, it means to take that quantity times itself. So we're going to do x squared minus 4x plus 4 times itself. And this is where it gets a little tricky, because there's a lot that's going to happen next. This next piece with the 2, we basically just need to distribute that 2 through to those 3 red terms. So we're going to get plus 2x squared. Positive 2 times negative 4x would be negative or minus 8x. Positive 2 times 4 is going to be plus 8. Then you have that little plus 3 on the end. Don't forget about that. Next, we're not going to worry about the negative sign out front. What we are going to do instead is we're going to have sort of 3 different activities involved. The negative sign is going to just sit out front and wait to see what we end up with in here. See, we're going to have to do x squared times x squared times negative 4x, and x squared times 4. That x squared needs to be distributed through to those 3 terms. I'm going to do those in blue. X squared times x squared is x to the 4. X squared times negative 4x is negative 4x cubed. X squared times 4 is positive 4x squared. That's what I get when I do those 3 blue arrows. Next we'll move to the negative 4x. That needs to be distributed through to the x squared, to the negative 4x, and to the positive 4. So each term from the first set of parentheses needs to be multiplied by each term in the second set of parentheses. So if we follow that, we get 4x times x squared is negative 4x cubed. Negative 4x times negative 4x is positive 16x squared. And negative 4x times positive 4 is negative 16x. I'm still not done with that. I need to multiply the 4 times the other 3 terms on the right side. So this 4 needs to distribute to the x squared, to the negative 4x, and the positive 4. We'll see that here in orange as I get positive 4x squared, negative 16x, and positive 16. Now that entire quantity, you see 9 terms there, that's just the first part of this problem. We still have the plus 2x squared, the minus 8x, and plus 11. That just comes from me combining 8 and 3. Finally, we need to distribute this negative sign through to every term inside that parentheses. So it's going to be negative x to the 4th plus 4x cubed minus 4x squared plus 4x cubed. That negative sign is basically carrying through and making every term the opposite of what it was. Minus 4x squared plus 16x minus 16. And we still have these guys to contend with. That negative sign does not make those negatives. They're just going to carry through as plus 2x squared minus 8x and plus 11. Your last step is to combine any like terms that you see. This negative x to the 4th does not have a like term. 4x cubed has another 4x cubed making 8x cubed. I don't see any other x cubed terms, so we have plus 8x cubed. We're done with the x cubeds. Let's look at the x squareds now. Negative 4x squared, negative 16x squared, negative 4x squared, and positive 2x squared. Let's see, negative 4 minus 16 is negative 20. Negative 24 plus 2 coming back into the positive, so that's negative 22x squared. Cross out the x squareds because now we know that we're done with them. Finally, I have 16x and another 16x and a minus 8x. They would combine to 32 minus 8. That's going to be plus 24x. And finally, the negative 16, let's cross those out. The negative 16 and the positive 11 combine to negative 5. This is my final answer. And one other thing, I know it's correct. You can check this if you want. You can use your graphing calculator to put this in y1, and you'll get a funky looking graph. Put that into y1, and then go back to the very beginning when we first made our substitution right here. Plug that into y2. Little trick here to see if you're right. Graph this, graph this. 1 in y1, 1 in y2. If they make the same graph, you simplified them correctly. Go ahead and try letter F. I gave you the answer to that in class today, but if you missed it, for letter F, the final answer was x to the 4th minus 4x cubed plus 2x squared plus 4x plus 1. Try doing g of f of x and see if you can simplify it to this same answer that I have here. If you do, you're in good shape and you're doing a good job with combining functions.